Problem 12, AMC 10A 2005, the figure shown is called a trefoil, and is constructed by drawing circular sectors about the sides of the congruent equilateral triangles. What is the area of a trefoil whose horizontal base has length 2? So I've already did some pre-work, and I've labeled my sides to show you that they're all congruent and that they're all 1. And from this, so a technique for tackling with geometric problems like these is to try to simplify things. We have 4 equilateral triangles, and we have 4 these things, which I forgot the name of it, but it's the circular sector minus the triangle. There is a specific name to this, but I'll just call it uh, a semicircle, if you will. And 4 equilateral triangles and 4 of these semicircles, we can form them together to each form a individual circular sector, which is what this is called. A circular sector is basically a portion of a circle. And 4 of the areas of these circular sectors will give us the total area of this trefoil. So let's do it. How do you find the area of a circular sector? Well, this should be quite common sense to you. This will be equal to the theta angle of the circular sector, so that would be this angle, divided by the 2 pi of the total angle, 360 degrees of its circle, multiplied by the area, pi r squared. This should come as no surprise to you because this is a portion of a circle area. So this must be equal to, in this specific scenario, the equilateral triangle's angle. Now the equilateral triangle, all angles are pi over 3. So pi over 3 over 2 pi times r squared, which is 1. Now pi and pi can be canceled out to get pi over 6. So the area of one circular sector is pi over 6, and we need 4 of them. So we can just multiply this by 4 to get 2 pi over 3. A technique within solving geometric problems like these is to reshape, to try to use the given shapes in the given areas and to make a familiar shape that you're capable of easily tackling with. So the answer is obviously B. But we could have obviously approached it another way. The area of an equilateral triangle is just root 3 over 4 times the side length, which is 1 squared. And we multiply this by 4, we get the square root of 3. And we could have added this by subtracting the areas of the circular sector with the equilateral triangle to get these respective portions. But that would have been much more time consuming, and it would have been much more easy and likely for us to make a mistake. So we see here why this is the most optimal solution, to think outside the box and to utilize the information you're given with to construct something that you're familiar with. But nonetheless, the answer is B.